it. Go here. -x2. Okay, we're set up. Let's get something. Okay, find this. Sorry. Hey, Henry. Okay, let me know if the stream has any delay on the video. It always feels like it has a delay. I'll figure out some music next time. There's a delay on the video? Okay. Hi, Peter. Hi, Daniel. There's no Peter. Depressing. Hey, someone. It's like 50 seconds for the video. Okay. Okay. Hi, Drew. Okay. We'll start in a second. You guys got the notes, correct? So the notes are, 1 second. This page, this is the notes. Is it delay for the chat or is it delay for the video? Feed feels like it's delayed. Can't change anything. Okay, here's the notes. Okay, we're gonna go through them. Okay, let's go through them. Need to grab my notes to make this easier. Okay, so in the chat, I want you to write. Actually, you don't need to write it. But, you know, if you want to be my favorite for the moment, just kidding. You can write what are our standard equations for a parabola and an ellipse. So what are the standard equations for a parabola and an ellipse? Secondly, if you can recall, what is the definition of an ellipse? Okay, so standard equation for a parabola. So this is what we're going to be typing in. Hi, Annie. So we're going to go straight into notes. Sorry, I am going to go to our notes. Okay, so our standard equation for a parabola. Let's just make this larger. It'll be easier to work on this for at least a moment. Transition. Okay, so the standard equation for a parabola is going to be x minus h squared equals 4p y minus k. And then also then we also get y minus k squared equals 4p x minus h. Hi, Catherine. It's good to see you. See you in the figurative sense. In the literal sense, you are not here. Okay, so this would be for, again, a vertical axis, and this is for the horizontal axis. Okay, just a reminder, a parabola is all the points equidistant from the fixed line directrix and the fixed point, the focus. Okay? So that's a parabola. Okay, these are the most helpful definitions. Just remember that we find out that the directrix is just y equals k minus p, and this would be x equals k minus. So this is just a reminder, guys, of a parabola. Okay, we'll go to an ellipse. So the definition of an ellipse we'll talk about in just a moment, but let's talk about its equation. So there's two equations we have. We have x minus h squared divided by a squared plus y minus k squared divided by b squared, and then this is all going to equal 1. Okay, so that's one of our equations, and our second is going to be same thing, x minus h squared divided by b squared, and then plus y minus k squared divided by a squared. Okay, and this is all over 1. Okay, hold on, let me make this closer together. It's not so far apart. Okay, and okay, so this will be the, apologies, just turning in the book. So this is the horizontal one, and then this is vertical. Okay, and the definition of ellipse is this all points the sum of whose distances from the two fixed points. So this is basically, this is just the key term here. The key term here is the sum, okay? So the sum of whose distances from the foci is constant. Okay, we're going to talk about hyperbola here, and not the exaggeration, but the actually mathematical version of this. So we're going to be talking about that. Okay, so this is just a reminder. These are the equations we need to know. Okay, it is a very good chance that these kind of equations will be on a test in the future, so it's a good thing to know them. Now, on the test, it will be an open notes test. That doesn't mean it's easier. That actually, in fact, means there's more challenges to it. But that's all we can do. Okay, so we're going to move to hyperbola. So the definition of a hyperbola is a hyperbola is the set of all points and this is just x comma y in a plane. The difference, I'm going to bold this, difference of whose distances from the two distinct fixed points and this is just the foci, is a positive constant. Okay, the difference is a positive number. Okay, that just means no matter how this turns out, they're going to be positive values. Okay, and in this section, actually right here, we're going to give the drawing. So we're going to minimize this a little bit. Not minimize completely, but it's okay. Okay, so we're going to be doing the drawings. So the drawings, now this doesn't mean this is exact. So if we have a point xy in the plane, the distance d2 and d1. So if you subtract d2 minus d1, you'll get a positive constant. Okay? Now it doesn't matter. It doesn't matter if this is any point along this side or any point along this side. It will give us a positive constant. Okay? Okay. That is the drawing, but the elements we need to take into account. So this is one of the drawings. Let's get the second drawing. Okay? So if you want to pause this video real quick, or don't pause it, I'll leave this up for a moment. So basically, again, hyperbola means the difference between this distance, the foci here, and the foci here. The difference between these two distances is going to be a positive constant. Okay? It stays the same, but it is always a positive. Okay? This is one of our drawings. Now let's actually look at what hyperbola each part means. Okay? And we'll go into the definitions later. We'll just label it, okay? So, yeah, we'll just go into it. Okay. So let me do this. Okay. So this is our center. We still have a center of a hyperbola. This and this are our vertices. Sorry. Okay. Our vertices are where the hyperbola hits the, and then this line that keeps going, that's called the transverse. Sorry, I'll write in bigger letters. The transverse axis. Okay? And these two, the things that go out, are branches. Okay? And we have, again, this is a foci and the other foci. Okay? So, that will be, sorry, I can't read it. Okay, so that's the branches. These two are the branches, and these are the foci. Okay? So, we'll move on to the standard form of the equation. So in our notes, I'll leave this up so you can keep it, but I'll be moving to the notes. So let's do this. Okay, I'm going to just zoom into the notes so that it's in much closer. Okay. Apologize, people. Okay. So we're going to go in the standard form of this equation. Okay. So the standard form of a hyperbola is going to be is going to have subtraction in it. It's a difference. So we're going to have our x minus h squared, okay, divided by a squared. Okay, same thing, same formula, almost as an ellipse, but the difference is there's that subtraction. Okay, so if you look at this, only difference is going to be that subtraction symbol. Okay, same idea, just it really likes moving into the middle. Okay, so we have our two forms, x minus h squared divided by a squared, and x minus h squared divided by b squared, and the y will have whatever is left over. So in this case, it is our a squared. Now, a is usually a bigger one. A is our bigger one, just in all cases. So if a is under x, this will be horizontal. Okay? A horizontal, just say horizontal transverse axis. I'll show you what that means. And then this one would be a vertical transverse axis. Okay, I'm going to blow these up. Okay? Any questions? Feel free to ask them right now. Okay, any questions? Feel free to ask them right now. Okay? So, feels like that's not zoomed in enough. Or that it's just not. Okay. Okay, there we go. We're zoomed in. Okay? So, again, this is if the center is h comma k. There is a different one, which would be if the center is at 0, 0. Of course, the 0, 0 one. Yeah, thank you, Daniel. I saw it. Thank Microsoft Word for being picky about this. Okay. Okay, so this one over here is going to be if the center is at the origin. Okay? And the center at the origin is just a beautiful equation. X squared over a squared minus y squared over b squared equals 1. Okay, beautiful equation, very simple. No extra parts. And then that's the horizontal. Sorry, I'm going to write both of these on the same line. Horizontal. Okay, so then the vertical will just be x squared over b squared minus y squared over a squared equals 1. And that will be vertical. Okay? Any questions about this? These are just our equations, okay? We're going to talk about how to use them and how to understand them, okay? So this is if our axis is horizontal with a center that is not at 0, 0. This is if our center is at 0, 0, okay? And I'm going to leave that there for a moment. If you need to stop me so that you can copy notes, please feel free to do so. I don't want to go too quickly. Okay, that'd be not fun. What are these? That is a great question. You know what? I'll learn it tomorrow. Okay. Okay, we're gonna move this. Not that. Big thing. Okay, we're going to go into some of the questions from there. Oh, first, our definitions. Sorry, definitions. So, what is a branch? Branches are the line of the hyperbola. Are we finishing the section today? Sorry that this is delayed. We're covering just 10.4, okay? Just 10.4 today. My goal is if we finish 10.4, 10.5 would be extra credit, which you don't really need. Let's just be honest. And we'll do 10.6 through 10.8 next week. The test would be the next week after that. Okay. So, that being said, and yeah, I'll talk to you guys about some stuff. Okay. So branches is the two disconnected lines of the hyperbola. Vertices are obviously where the transverse axis intersect the branches. And then the transverse axis, the line through both foci. Center is the midpoint of the transverse axis. Okay? The center is the midpoint of our transverse axis, and these are just our definitions. Okay? So branches, two disconnected lines of the hyperbola. Vertices, where the transverse axis intersect the branches. Transverse axis, the line through both foci, and center, the midpoint of the transverse axis. I want you to note something. There is one difference between how our A and our B and our C relate. So, in ellipse, actually let's blow this up again. Apologies, this just takes a second. Okay. And an ellipse has the formula c squared equals a squared minus b squared. Okay? That's an ellipse. And a hyperbola has the formula c squared equals a squared plus b squared. Okay, so a hyperbola is going to have a different formula for our c. Okay, find c. And sorry, just double checking so I don't lead you guys the wrong direction. Okay, so hyperbola is going to have, hyperbola is going to involve right triangles. Exactly the case. Now, is it the triangles you're used to? No. Okay, so we're going to look at a graphic. Just to confuse you, this will be the simplified graphic. So it will obviously get more complicated as we go. Because, that's just how this works. Okay, so let's blow up this. Sorry, it's way too glowing. There we go, sorry. Okay, so our graphic. So we get, I'm going to draw them both on the same area. Okay. Okay, so this is H, comma, K. Okay. Sorry, that's small. I'll write it a little bit bigger. This is H, comma, K. Okay. And this point is our focus. Its formula is H plus C, comma, K. This point is H minus C, comma, K. Okay? Our vertices are going to have a different formula. So our vertices are going to have H minus A, comma, K, and H plus A, comma, K. Okay? And the formula for this one is the x minus h squared over a squared minus y k squared over b squared equals 1. Okay, so this is the horizontal one. Okay, vertices again have A involved, and our foci have C. Okay, now the vertical one is going to look like this. Okay, again, H comma K is our center. This would be H comma K minus C and H comma K plus C. Again, so our vertices would be H K plus A and H K minus A. Okay, and this is just the one where the A and the B switched where they were. So B squared would be under X squared, and A squared is under Y squared. Okay, sorry, apologize, there's not much I can do about that light, but I'll get better lighting this next time. Okay, so this is our two graphs. Okay, so horizontal, traverse, vertical, traverse. Okay, vertical, the A is under Y. Horizontal, the A is under X. Okay, I'm gonna sit here. You know what? Give you a little bit of time to graph this. Make sure you get the graphic correct. You do want to practice graphing it, so I would recommend doing that for this first one, okay? Okay, and while we do that, I'm going to try to find out if I can get my hands on some classical music that's not terrible. Well, of course, classical music is not terrible. Oh, this sounds good. This is a guitar. I'm gonna wait for, obviously, you guys to graph this. Once you say yes, then we'll move on. Okay. So once you finish graphing, let me know, and I will move on. Okay. That was 45 seconds. Plenty of time. Okay. Okay, we're moving on from the graphic to finding the standard equation of the hyperbola given different characteristics, okay? So our first one, we are given the foci and the vertices, okay? Foci and the vertices. So we need to erase our board. That was plenty of time. You can always go back and get this graph. Okay? So it gives us our foci and our vertices. Now we need to know, what is C? Well, C, so, okay, we need to find the midpoint. So we have our 2 points, -1, comma 2, and 5, comma 2, apologies, and the vertices are 0, comma 2, and 4, comma 2. This is our foci, this is our vertices. So what's our center? Well, our center is the midpoint between these two. The midpoint between 0 and 4 is 2, and 2 and 2 does not change, so that obviously will be our center. Okay, so we have our center. Now do we have C? So C is the distance between the center and the 5. So C, little c, equals 5 minus 2, because this is what's changing. 5 minus 2 gives us 3. A equals 4 is 2. So 4 minus 2 equals 2. Okay? Well, c squared equals a squared plus b squared. So 3 squared equals 2 squared plus b squared. So 9 equals 4 plus b squared. 5 equals b squared. So b equals square root of 5. Or you could say you have b squared equals 5, and a squared equals 4. So our equation, now is this horizontal or vertical? That's a great question. How do you tell? What changed between our vertices? Did our vertical change or horizontal change? Okay, horizontal changed because it's the mid. Okay, the mid, that x changed. So we know how to write this. Okay, so it's x minus h, that's x minus 2 squared, over a squared, or 4, minus y minus 2 squared, and then what's our b squared is 5. Okay, sorry, I'm going to rewrite this in a different section. Okay, my apologies. I thought I had enough space. Clearly I don't, so I'm going to take out our foci and our vertices. So we get x minus 2 squared over 4 minus y minus 2 squared over, sorry, why is b bigger than a? Nevertheless, usually it's not, but sometimes it is. Okay? And we get that. Okay? So sometimes the b will be larger than a in, and only in, hyperbolas. Okay? So really, all the rest, so ellipses mainly, have a bigger than b. But hyperbolas can have either one bigger. Okay? Now, that's our standard equation, so we're done. Okay? So key steps. Find your center, find a squared and b squared. Okay? Find your center, that's where you put this. Find a squared and b squared. So let's look at the next question. Okay? Now the next question gives us the foci. And let's move this over so it's actually going to give us the most possible space. So foci is going to equal 0, 0 and 8, 0. And our vertices are going to be 2, 0 and 6, 0. Okay? So let's work this out together. And then there are some, there are some practice problems you guys can work on. Okay? Okay. So, okay, what's the midpoint between these two vertices? Between 2 and 6, the midpoint is going to be our center. Okay? The midpoint is 4, 0. How do you find the midpoint? You add these two, 2 plus 6, and then divide that by 2. So 2 plus 6 is 8, 8 divided by 2 is 4. 0 plus 0 is 0 is 0, so you don't have to deal with that. Okay, now, what's our A and what's our C? Okay, well A is the distance between this and this. So 6 minus 4 gives us a 2. And C is the distance between this 8 and this 4. So 8 minus 4 gives us 4. C squared equals A squared plus B squared. So 4 squared equals 2 squared plus B squared. Okay, so 16 equals 4 plus B squared. So B squared is going to equal 12, or B is going to equal 2 square root of 3. If you want to do the math, I did the square root in my head, but you're free to use a calculator to double check. Okay? Now again, double checking. Is this vertical or horizontal? Vertical would mean our y changes between our foci, and horizontal would mean our x changes between our foci. Well, our x changes. So, x minus 4 squared, we have our center in there, over 4, which is a squared, minus y squared. We don't have 0, we don't worry about the 0, we just put it by itself. So y squared over 12 equals 1. Okay, this would be our equation. Okay, finding the standard form of hyperbola, especially these ones with just foci and vertices is much easier, okay? The challenge will come in when you have it pass through a point, or there's some other ones that are going to be a little bit more challenging. So let's look at some of the practice problems, okay? Let's do a practice problem, okay? So, you can choose one of these practice problems. Load these practice problems up so you get them. Okay. So choose one of these practice problems. Sorry. That looks so much better. Okay. Choose one of these practice problems right here to do. Okay, this one would be the most like what we just did. This one right here. This one over here. This one also, very similar. Granted, its center's gonna not be on 0, 0. And then this one would be the most challenging. Okay, number 3 is the most challenging. So I'm gonna give you 45 seconds. I'm gonna do number 3. I'll write the answers for number 2 and number 1 on my board right here. Okay. So let's keep playing my beautiful song. Okay. What's this in the lips? Oh, huh. Good joke. Hyperbola. There's no way this is an ellipse. It's the problem. Okay. It's a hyperbola. Whoa. Okay. Sorry. I'm gonna keep working on this one. So I get 4b squared minus 5 squared minus 25 over 9 equals 1 over the 25 over 9 to this side. 9 over 9 plus 25 over 9. And I get 4 over b squared equals 34 over 9. Multiply b squared by both sides. And then I'm going to get 4 equals 34 over 9 b squared. Multiply the reciprocal. 36 over 34 equals b squared. Well, it's square root. Get 6 over the square root of 34 equals b. Well, actually, we don't need to worry about that. We have this right here. So, we have that. We're going to plug that back into here. So our final answer is going to be x minus 2 squared over, it's going to be 36 over 34 minus y squared over 9 equals 1. Okay, so, real quick, I did the harder one. The easier ones I will write the answer to in just a moment. So let's, looking at this board real quick. So first I took I took the vertices and I found the center. After finding the center, I found A. So then I was able to write this equation, but I didn't know what b squared is. So I had to solve b squared. So I plugged in the point for x and for y. That's what I did right here. Plugged it in, and I just solved for b. So all I'm doing is doing everything to get b by itself. And then as I go over here, b squared, I multiplied to both sides. Then I got 4 equals 34 over 9 b squared. Got b squared by itself. And then this is our answer. And then I just plug that number back up here. Okay? Now, is this a nasty number? Yeah, but it is doable. Okay? So if you want to pause the video and look at how I work this, that's fine. I'm going to show the answers to the other two. So the other two are going to have not too challenging answers. So this is 29 and apologies, 29 and 37. So 29 is going to give us y squared over 4 minus x squared over 12. See, you know what? I may have done something really wrong. Oh yeah, I did. Shoot. My apologies. So when our y's change, the y should be positive. And just realize. So when our vertices have the y values change, the y should be positive, the x should be negative. Go back to that in a minute. Frustrating. Okay, this is the first one. So the first one, the second one is going to have, it's going to have the equations y minus 5 squared over 16 minus x minus 4 squared over 9. Okay, I need to explain something real quick. Dear Lord. Okay, I'll come back to this camera so you'll be able to look at it if you need to. Okay. My notes. Okay, this right here. The problem. Okay. The A is always going to have to be positive. So this is where my garbage brain didn't remember. Okay. My garbage brain forgot that vertical. Is going to change this. Okay. Basically, This is the thing with hyperbolas. Hyperbola, the a squared has to always be under the positive. Okay? The a squared always has to be under the positive. That's where my garbage brain forgot. I don't know why they don't like this anymore. Okay. So the a squared always has to be under the positive. My huge apologies. Okay? That was some reason I didn't register it. So a squared is always going to be under the positive, and b squared is always going to be negative for hyperbolas. So it doesn't matter about greater or less than, it just matters about where is the positive. Okay. So that's why our two answers are going to have the y as positive. Okay. Okay. We're going to move on. Okay, we're going to talk about asymptotes. Now, the equation for an asymptote is, I'm actually going to write on both. Try to juggle this act. Okay? If you want to know what an asymptote is, it's not exactly a beautiful drawing, but you know, it is what it is. Okay, so the asymptotes are lines that pass through our center that inhibit where they inhibit our branches. So they don't let the branches go too far. So these are our asymptotes right here. Okay, these are our asymptote. And then if you see this goes up right here, you see this box right here, well, this is going to be our hk plus b. So this is where our b comes in, and our hk minus b. Okay, so our b affects this little box thing. It doesn't affect the vertices or the it doesn't affect the vertices or our foci. So B affects the asymptote. Okay? And our asymptote is going to have two equations. So horizontal is going to be y equals k plus or minus b over a x minus h. Okay? I'll write this in the computer so you will also get it. Blow it up to be larger than life. Okay. So we get y equals k plus or minus b divided by a x minus h. Okay, so that's horizontal. So then you may be like, well, David, what about vertical? Great question. Great question. So vertical is going to be y equals k plus or minus a divided by b over x times x minus h. Okay, so our horizontal, I'm going to rewrite this so I know this drawing is beautiful. It is in your book. Everything is in your book that I go over. Okay, so horizontal is y equals k plus or minus b over a x minus h. Okay, vertical is going to be y equals k plus or minus a over b times x minus h. Okay, the key difference is slope. Okay, key differences are slope. Okay, so we are gonna let's load this up. Okay, so that is our asymptote. Asymptotes are the lines that limit the function. Okay, they provide a limitation to the extent at which this function can go. Okay, think of it as more like when you have, sorry, my apologies, 1 second. When you have a tree and someone puts a guide rail around the branch is forced to go one direction. And if it tries to go out, it's cut off. Okay, so the asymptote effectively limits where this will go. Okay, so we're going to go to the next questions, example 2, and it says sketch the hyperbola whose equation is. Okay, so we're going to sketch the hyperbola, and the easy way of sketching it is using the asymptote. Okay, I'll show you what I mean. If you use the asymptote, you can draw this really easily. You don't have to find any more points. It makes it straightforward. Okay, so our equation, I'm going to write it at the top. Okay, apologies, just get this. Okay, equation. Let's use a different color. Board with that color. Get 4x squared minus y squared equals 16. Okay? Now, easiest way, let's divide both sides by 16. To get a hyperbola, we need to have 1 right here. So we'll get 1 equals y x squared over 4, y squared over 16. So what's our a and our b? Well, 4 is just 2 squared, so a equals 2. What does b equal? B, 16 is 4 squared, so b equals 4. Okay? Now, there's a way to do this in a calculator using there are ways. I'm not going to show you. It is a little too complicated for it to be worth it. So let's not try to use it with a calculator. Okay. So what's our what do we have now? Well, our center is at 0, 0. Okay, our center is at 0, 0. So graphing this, I know this is not straight, but this is as good as we're going to get it. So this is our 0, 0. Wow, that is really crooked. Let's make this way straighter. And a little bit better, still bad. Okay, So we have our 0, 0. Now we add plus, b is on our y, so we add 4 to our y and 2 to our x. And we make our little box. Okay. Now you can use a dotted line for this box. So let's just redo that so you can see it's a dotted line. It isn't a solid box, it's just, hey, dotted line, dotted line. And our asymptotes are going to go from the center to these corners. So asymptote goes this way, goes down this way. Our other asymptote goes through this center and through this corner. Okay, it keeps going. These keep going. Okay? Now, key point, how to draw this. So you have your vertices on the A. Okay? Right here. But we need, and so really, this drawing, the line is going to push out and go closer to the asymptote. So it's going to push out and go closer to the asymptote. Now it's not going to curve away from the asymptote. That's just poor drawing, okay? So it's going to go from the center, from the vertex, and push out towards the asymptote. Okay? Now, we're not finished yet. We still need to draw a focus. To find the focus, we just do a squared plus b squared. So 2 squared is 4, 4 plus 16. It's just a squared plus b squared equals c squared. So c squared equals 20, which means that c equals 2 square root of 5. So 2 square root of 5 is going to be here. Well, actually, it's actually going to be closer to here. Okay, so these are how you draw a, I'm going to try to finish in the next 10 minutes. Let me see. Is there any other ones that we need to do? Oh, using asymptotes to find the standard equation and the graphs. Okay, so here's what I'm going to do. I'm going to not speed run this, but I'm going to go decently quickly. And when I go decently quickly, you're going to try to, just know I will come back over. I'll make a video of any questions you have on the homework. Okay, I'm going to do the homework quiz for this because this is because the last one we did was a while back. So I'm going to do a homework quiz for this one. Okay, so this is asymptotes. Drawing with the asymptotes, pretty straightforward. Okay. It gives you the center, and you can find out the other aspects. Okay, so there's a practice problem on the notes. For this, feel free to do it. Okay? Now, I am going to move on. Okay? So, using asymptotes to find the standard equation for the hyperbola. So, standard equation is going to be, if you see the vertices, they give us our vertices. So they give us A. So our vertices are 3, negative 5, 3, comma 1. So if they give us that, and m equals 2, which is equal to a over b, well, what changed? So our vertical changed. So in this case, if vertical changes, this is a over b, and to find a, we find the center. So center is going to equal 3. What's the midpoint of this? Well, this is negative 5 plus 1 is negative 4, divided by 2 is negative 2. Okay? So what's the distance between the 5 and the 2? Or 1 minus negative 2 is going to give us 3. So we're going to have 3 as A, okay, over B, and that equals 2, so 2 equals 3 over B, or B equals 3 over 2. Okay. Homework quiz, it's just what questions you have on the homework. That's what a homework quiz means. Okay. So to write this out, we get, this is vertical, so y is going to be over A. Y plus 2 squared over A squared, which is 4, minus x minus 3 squared over B squared, which is 9 over 4, so B squared equals 9 over 4. 9 over 4 equals 1. So you can write it this way right here. Okay. So we take our vertices and our slope and we use them to find out what A and B are. Okay. So our slopes give us A over B or B over A. Okay. The second question right there, number 43, is going to have B over A. Okay. Which means, which means you're going to just use B over A over here and solve it that way. Okay. I'm going to move on, but I will provide a video of things you have questions on. Okay. I know that was very quick. So if you have questions on the homework, please feel free to ask me. Okay. Okay. Last part. General equation of conic sections. Let's blow this up so you guys can see it. Okay. Classifying conics in its general equation. Okay. The graph of what does A equal, Fiona? Oh. Sorry, it equals, it's supposed to equal 9. It equals 9. It's supposed to equal 9. Oh, yeah. I can correct that later. Okay, the graph of the equation. Ax squared plus, here, okay, plus c y squared plus dx plus ey plus f equals 0. Okay, if you notice there's no b right here, and we won't ever learn about that because that's more complicated. Okay? Let's just skip it. Just gone. Okay? Now, there's 4 different types of conics. A circle, which we haven't really dealt with that much, is if the equation A equals C. Okay? If A equals C, then it's a circle. A parabola. is A times C equals 0, okay? So parabola is A times C is equal to 0. Ellipse, if A times C is greater than 0, okay? A times C is greater than 0. And hyperbola, if A times C is less than 0, okay? These are our this is how we classify them. Okay. Honestly, this is the probably easiest part of this whole chapter, right here. Okay, so we're just looking at this A and this C. Okay? If there's no y squared, then it's a parabola. Okay? If there's no x squared, it's a parabola. If A and C are equal, it's a circle. If A times C are greater than 0, it's an ellipse. A times C is less than 0, it's hyperbola. Okay, let's look at some questions. This one, okay? Do we see a y squared in this question? Well, no. We see A, so this would be A times C. 4 times 0 is equal to 0, which means it's a parabola. Okay, that's the first one. What about our second one? Okay, what's A times C? 4 times negative 1 is going to equal negative 4, which is less than 0. Okay, looking back at the top, if our A times C is less than 0, that's a hyperbola. So we say hyperbola. Okay, A is 2, C is 4, so A times C, 2 times 4, is going to equal 8. 8 is greater than 0, which is greater than 0. A times C is greater than 0, it's an ellipse. Okay? And next one, we have 2 and 2. Now, are 2 and 2 equal? A equals C. We're done. We just write, a circle. Because 2 equals 2. Okay? Okay, this one is an ellipse because they're both positive. So 4 times 9 is 36. This one, both are equal, is in a circle. And the last two, I think you can solve. So, we're done, but if you have any questions, feel free to ask me. Okay? We are finished, but if you have any questions, feel free to ask me. Okay? So, I will upload the link to this video, so you have access to it. And I will upload homework help. Okay? Thank you guys so much. I will talk to you on Monday. Okay? So next class will be on Monday. Okay? Thank you so much, guys. I'm sorry that I didn't answer questions quickly. We'll try to do it. I'll try to do better next time. Bye.